And welcome back. We are going to take a deeper look at Java today, and we're going to kind of see a little bit more about what makes Java programs kind of work the way they do. So the first thing we have to do is we have to take a step back for a second and have a bigger understanding of programming languages in general. So as we have talked about before, Java is an object-oriented programming language. Now, another term that sometimes gets used instead of object-oriented is high-level programming, and it just refers to the level of which this programming language is using. Reason why we call this high-level programming, well, these are languages that are typically easy for the programmer to understand and to write. They're not written out in machine language or code. And the reason for that is because we want, again, the programmer to have them be easy to use. Where we compare that to a machine language, these are languages that the computer can directly understand. Look at something like binary. It's a sequence of zeros and ones. Well, for a computer, that's really easy to understand. But for a programmer, that can be very tedious and very difficult to troubleshoot. So we kind of get this trade-off where machine languages are, easier for the computer but harder for the programmer. But a higher level language like Java is easier for the programmer, but we get the trade-off of it being a little bit more tricky for the computer. So there has to be some steps that go on to make it be able to be usable. So that step, of course, is using what's called a compiler. All right, so for Java or any other object-oriented language to run on your computer, it has to be translated from the plain English or whatever language it's written in to be written over into the computer code that we needed to be able to use. Now, that process that transforms it from what we've typed on our screen, like our Hello World program, for example, and turning it into a language that the computer can understand, that process is called compiling. So it goes from the compiler to compiling. Now, one big advantage of Java is that it has a kind of built-in interpreter and compiler for the native language of whatever machine is being used on. You don't have to necessarily bring in a bunch of libraries and stuff like that in order to do all this troubleshooting and hoops and you gotta work through. It already has that kind of built in. Now, this language that Java has kind of running under the hood is called bytecode. So let's think back a second here and remember when we did our Hello World program. Remember when we pressed that start button in Eclipse? It went and did some magic and then it ran it. And then down at the bottom of our console screen, it showed the words Hello World. All right, that's because it executed via the run command in what's called the Java virtual machine. That virtual machine is when it took our code that we had written and converted it over into bytecode. Now, the program that we are writing, that we, the programmer, are responsible for, is what's known as a source program or source code, because that's the source that we're writing in. The thing that the computer is going to produce is what's known as an object program or object code. And, if you were to open up the actual files that get generated, so for example, it creates, for example, a .java and a .class file. That .java file, you open up, oh, this looks just like the code that we've written. You open up the .class file, it's going to be kind of some gibberish that you can't understand because, again, it's a way for the computer to understand it. Now, when we actually look at our Java programs, all right, I mentioned this term already once before, and we've talked about it in our last lesson, but we are creating classes. All right, these are the things that are compiled to be able to run. So remember, we had like public class, sample program. Or let's say we look at another example here. Let's just make a new one. We're just making up here, and we say, hey, we got a program. We're going to call it first program. Well, the file on our computer is going to be called firstprogram.java. That is our source code or our source file. If we open that file up, open up firstprogram.java, it's going to match exactly what we had written in first program. Now, little thing to note is that we only have one class here in this example. You can, of course, have multiple classes, but that's something that we're not going to worry about at this time, so don't even stress about that right now. What I do want you to know, though, is that we compile our code by creating the resulting bytecode. Remember, I already talked about there's a Java file and there's a class file. Well, if we use firstprogram.java and we run that code and compile it, it's going to generate a firstprogram.class file. And that .class file, of course, is our bytecode. And so anytime we go and create a class inside of Eclipse or whatever IDE we're using, it's always going to create a Java and a class file. Now, we need to make sure that we talk about the syntax and some semantics when we're looking at Java. Just like any written language that we have, like it's English, Spanish, French, whatever, programming languages also have a set of rules that they must follow. And we, think about, let's say English. You have grammar, you have punctuation, you have capitalization, all these different rules that you have to follow. Well, Java also has some certain rules that we follow. The most important of these is what's known as syntax. All right, and this is simply what we call the arrangement of words and punctuation that would be legal to use in a programming language. And when examining our language for programming errors, syntax errors are always the easiest thing to find because they often prevent our program from being able to compile in the first place. So if we can't compile it, we can't run it. If we can't run it, well, that means we have an error. And most of the time, that error is going to be a syntax error. Now, I threw around this term semantics. Semantics is important because this is the meaning of the words written while following our syntax rules. So think about our Hello World example. When I talked about system or I talked about print line, all these different things have meaning. They are there for a reason. And we can get a little further in and we'll start talking about some different terminologies about what some of these different words mean. But for now, we just need to know that there's a reason why we're using these words the way we do. Now, I already mentioned errors, and I already talked about the first one, of course, is a syntax error. But let's see how that actually looks in order to get a better idea. So here's our Hello World program again. All right, and it looks like our Hello World program. Public class Hello World, public static void main string args, system out println Hello World. Okay, great. But there's an error here. Now, what is that error? If you don't know, go ahead, pause the video for a second, take a look at that code and see if you can compare it against our original Hello World program and see if you can identify what is missing. All right, hopefully you went ahead and pause that video. If you didn't, this is the chance to go ahead and dive in and find out what's missing from this Hello World program. And of course, it's a semicolon. We are missing a semicolon after the systemout.println hello world. That semicolon is what tells Java, hey, this is the end of that line of code. And so if we don't have it there, we're going to have a syntax error because it's going to look and say, hey, I'm expecting a semicolon here. Did you maybe forget to put one in here? Well, this is an example of an error. And as I mentioned, errors are things we're going to have in our program. Syntax errors being one of the most common ones to easily find. But these are more commonly or colloquially known as bugs. All right, the bugs are things in our program that, of course, are errors. And the process of fixing these bugs is known as debugging. All right, you might have heard the term bugs and debugging, and now you're going to get to experience them firsthand as a programmer. Now, there are three types of errors that we're probably going to encounter most commonly. And every kind of error that you can kind of come across kind of tends to play from one of the variations of these errors. You can get more specific with your errors, of course, but generally speaking, most errors are going to fall into one of these three categories. The first one we've already talked about, which is the syntax error. This is simply just a grammatical mistake in our program. So as I've already mentioned in our previous Hello World example, the code was missing a semicolon at the end of our system.println statement. And because it was missing that semicolon, well, that means we couldn't run forward with it. The next thing is what's known as a runtime error. Now, this is an error that is not detected until your program is run. So the program runs, the computer is going to display an error message that you may not understand, but it'll indicate that something has gone wrong. So this won't happen until we actually try to run our program. So our code looks fine. We don't see any red squiggles or anything like that, but it might be one of those things that pops up. The last one is a logic error. Now, with the logic error, this is typically something that is a little bit harder to find. This is what's called a mistake in your underlying algorithm. So you're thinking of how your program is done. So in this one, your program is going to run. It's not going to display any errors. But if you're looking for a specific output or a specific action, it's not going to give you that. Now, these kind of errors are typically the hardest to locate because, well, the computer and the program aren't going to give you any indication as to what or why. So these are the kind of errors that typically are the ones that, as a programmer, you're going to spend most of your time working on debugging. Syntax errors, super easy to find. Oh, you missed a semicolon. Great. Runtime errors, you run your program. Hey, I think something's missing here. Could you go back and fix it? Logic error. Oh, yeah, everything looks great. You run your program. That's not what I was expecting. All right, so now that we've looked at all these errors, let's quickly hop over to Clips and take a look at just a quick syntax error again, just so we can get some good feel with how this works. All right, and so I'm back into Clips here, and first thing I'm going to do is I'm going to go ahead and create a new project. Now, the one thing I want to stress here is that when we do a new project, we can, of course, come in here and technically erase this and, or add another class here, but I always like to do a new project every time I'm starting a new lab file, unless I'm editing an existing project. So for here, I'm going to right click, I'm going to do new Java project, and I'm going to call this lab 2. Remember, it can't have spaces, so I got to remember that. And make sure that module info is unchecked. Go ahead and click finish. And you see it's my lab 2, so let's go ahead and create a new class. And we call this one Hello Universe. Let's call this Hello Bug. And let's add our main method in there. Go ahead and hit finish. And I'm going to take this comment line out again. And let's go ahead and do system.out.println. And let's use the example that we saw before. So let's do hello world. And I'm just going to leave that there for a second. And just as you can see, we have this red mark here. And of course, a little red squiggle here. If I save it, you can see it still doesn't go away. If I try running this program, and I was like, I'm just going to try to ignore this error. If I try running this program, you see we get this message that says, hey, there's an error here. Do you want to proceed with launch? And if you try clicking proceed, you're going to get this error message that says, hey, you might need to include the semicolon to complete your statement. So I'm just going to go up here. Okay, I need a semicolon. Great. Go ahead and put that in there. And you can see that that red squiggle mark has now gone away. Now, if I were to do something else, let's say, oh, I have quotations here. What's if I forget a quotation, for example? All right, well, you can see we get the same thing here. But now you notice instead of that big red circle, we have this kind of light bulb with a circle and it says string little is not properly closed. Oh, what does that mean? Well, if I click on this little thing here, it says insert a missing quote. Oh, that tells me I probably forgot a quotation mark. So I can double click that, but notice where I put it is not the right place. So sometimes the compiler and Eclipse won't actually have the best guess, so it's good to just kind of look and see where you might have missed something. And we'll go ahead and save that. And the last thing I want to show you is, of course, when I run this program now, of course, it looks great. Hello world. I want to show you real quick, if I were to go into that project file, what that actually looks like to show you those two different class and Java files. All right, so I went ahead and opened up my project here where I have lab 2 created. And inside here, you'll see I have a bin and a source file. Now, just again, really quickly going to show you this. If I go inside my bin file, you see I have my hello bug program right here, .class. So this is my bytecode file. And if I go to my source folder, you'll see hello bug here. Now, this is, of course, currently open in Notepad. Yours may not. It may look kind of like how this one does, where it just has this white file. I've gone ahead and changed my program settings so that way when I open this with Notepad. That's just an option I have here, so I can quickly go and look at my code without having to fire it up in Eclipse again. But again, just wanted to show you those two differences there between those, because again, if I try to go and open up hello bug class, we're going to get a thing that says, I don't know what to open this with. So just something really cool and brief to look at as we get ready to dive deeper into programming.